Good morning, good afternoon also from my side. So today I will focus on new function blocks in the PLC Open Safety Library according to the specification version 2, which was introduced in Automation Builder 2.7. With that, we think that the customer can do his safety engineering faster, and with standardized function blocks, he has a much more open solution, which he can easily convert from one PLC brand to the other. We, of course, hope that our safety PLC is the best one, and he stays with us. So it's an opportunity for us. And then we benefit from this standardized and open approach offered with the AC500 as safety PLC. So my role is the Global Product Manager for Safety PLC. I'm responsible also for Profinet and ProfiSafe. And I will start with an overview of PLC Open Safety, what it is. PLC Open Safety is one of the specifications created by PLC Open Organization. You can see that it was founded back in 1992. It's an independent worldwide organization, and their purpose is exactly to offer efficient engineering to end customers by providing standardized specifications so that companies can implement their solution based on those specifications, and there is a possibility to easily migrate from one brand to the other brand. They have headquarters in Netherlands and also supporting offices in US, Japan, and China. There are more than 30 members in this organization, including ABB, Siemens, Beckhoff, and many others. Depending on their goals, some of these companies implement PLC open specifications or not. We are one of the fastest ones to accommodate PLC open safety. You'll see it today in further slides. So for example, the PLC open safety specification 2.01 was released in 2023, and we managed to implement it as part of our product portfolio already in 2024. This is our own developed PLC Open Safety Library developed by ABB. With that, customers have common look and feel, and they have the openness of PLC Open Safety to change the solution. The specification of PLC Open Safety function blocks is done using state charts, as you see here on the right side. This is a very simple example. Some of function blocks have much more complex state charts behind, and there are time diagrams used to explain the behavior of the inputs and outputs in relation to the PLC Open. And this all functionality is implemented, tested, verified, validated, and certified by TÜV South in Germany as part of SIL 3 Performance Level E portfolio of AC500S. And with these function blocks, you'll see also in my demonstration, you can implement almost any simple OEM machinery application. So PLC Open Safety function blocks is like a basis for safety applications. And as you know, some of our customers go even beyond that when it comes to mobile machines, if it's cranes, hoists, automated guided vehicles, and so on. But for simple machines like labeling, packaging, metal cutting, and so on, those function blocks are good enough. So what is new? Because I said that I will not be able to cover all 22 function blocks of PLC Open Safety. I will focus only on new function blocks and also on changes as part of version 2 specification. Please don't mix the version 2 of codices here and version 3. There was only PLC Open Safety specification version 1 before 2023, which was released. So version 2 is the latest, newest PLC Open Safety specification by PLC Open. And we introduced as part of Automation Builder 2.7, if you go to AC500S programming tool, you'll see that there is a new library. It has this name, and there are 22 function blocks listed there. And new function blocks are the ones which you see here in the list. It's SFPSE, guard locking 2, guard locking serial, reset button, enable switch 2, and override. I will cover each of them in a separate slide so you get a feeling how it works. And now in total with these 6 function blocks, so there were 16 before plus 6 more, we have 22 safety function blocks. And this is one of the biggest standardized safety library on the market. If you look some competitor products, then you'll see with the ABB portfolio you have the best coverage at the moment. Now a few words to compatibility, because we had since launch of the product this PLC Open Safety Library version 1.0, and it's still valid. It can still be used in projects, and it's offered in Automation Builder profiles smaller than 2.7. If you have existing project and you would like to migrate it to Automation Builder 2.7, we keep this library in the project so that you can keep possibility to compile your project without any warnings or errors because of new inputs or outputs of new function blocks. So if you would like to migrate from version 1 of PLC Open Safety Library to version 2 PLC Open Safety Library, you have to do it manually if you have created projects with Automation Builder smaller than 2.7. And of course, if you create a completely new project in Automation Builder 2.7, then the new library will be used, which I showed in the previous slide. So one of probably the question why the new library, when you include it, doesn't compile, because PLC Open Safety decided to limit compatibility to version 1.0, for example, by introducing in some function blocks additional outputs. You see them named here, safety demand and reset request as examples. You can see them on the next slide also in more detail. So for example, this function block override has safety demand and a reset request, and a few even existing function blocks have these outputs added. So it requires, of course, adapting your safety application if you would like to migrate to version 2. And for that purpose, we said, okay, we offer to you this other library. You see there is an addition ext at the end. There is a link how to download it from ABB library. And this library includes only 6 new PLC Open Safety function blocks, and exactly these ones, which are listed here. And you could add them to your existing application with PLC Open Safety Library version 0.1. With that, you can keep your existing safety application unchanged without any adaptations, and you can still use even new function blocks from version 2 in that application. So again, gives you a flexibility to decide what you would like to do. And on top of that, we also have a PLC Open Safety Library version 1.0.1, where some internal improvements were done for this function block SF_mu_team_par. And this improvement is included, so we recommend, of course, if you would like to stay with version 1 specification of PLC Open Safety, to change to this library version. And this library version is fully compatible from inputs, outputs with other library. But of course, if you compile it, then you'll get still a new boot project CSE for that. So you have to do some verification and validation procedures on top of that to be able to use your safety application as before. But again, other than that, this library is absolutely compatible with the previous one. Now we're coming back to the version 2, PLC Open Safety version 2 library. And I would like to highlight, and that's what I already mentioned on the previous slide, these new outputs. They are propagated in almost all, or used in almost all safety function blocks, even not the ones shown here. You remember there were 22 of them. And the main purpose of that is to give you better visibility in your safety application. What is the current state of your function block? So for example, this safety demand output, you'll see it also in the demonstration later on, shows you that the safety function is currently activated and there is a safety demand, then it's true. And if there is no safety demand, then it's false. The reset request Output is also very good because you see that in many function blocks, typically when you have some activities with these function blocks, you have to reset them. And that's why reset input is quite prominent. And it's really good to have it also at an output, to know that you have to press your reset button. That's what we will also do today. And then reset the state of the function block and then keep going with your safety functionality. So again, true indication that the reset is requested, false, reset is not requested. Now we'll come to the explanation of each of these safety function blocks. I will cover 4 out of 6 because 2 of them are quite complex to explain in this webinar. So please refer to our safety user manual for more explanations. But I will focus on the first 4 ones. And the first one, which was introduced in our library, is called SF reset button. This is a very useful function block because it allows you to set the trailing time, the minimum and the maximum time expected for the reset. So you are able to set the timing constraints on reset behavior, which is required by ISO 13849 standard, which is functional safety standard for machinery applications. It's also referenced in Machinery Directive and Machinery Regulation, at least in European Union. And you have to supervise how reset button is working, because reset button can also get broken and then probably the contact doesn't respond in expected timing intervals. And this is not good for safety applications because it creates some undeterministic state. And with that, the reset button helps to solve that. How it can be used, you see here on the next slide a good example. So it can be used just before our electrosensitive protective equipment. In this case, it's a light curtain, could be also some other device. So this S_ASPA_IN input is usually connected to the output of the light curtain. But then when something happens, you may need a reset of this function block. And to reset it, you don't connect the reset button directly or reset button input directly to the reset, but pass it through this reset button function block, which defines the minimum trailing time and maximum trailing time when the reset button is triggered. And only then it is accepted as a valid signal and then connected here to the reset output and resets the light curtain so that you can continue to use it as safety protective equipment. So very useful functionality. Up to now, customers had to create it themselves and did this, or some customers, depending on their requirements. Now you have a standard function block, which is standardized and tested, verified, validated, and approved for safety applications with AC500S. The next function block, which is also very helpful, is the monitoring pressure sensitive equipment. It's a PSE function block, which can be used with safety marts, with bumpers, basically devices detecting mechanical contact. And when it's triggered with the S_PSE_IN input, and depending, of course, on the settings on start reset, auto reset, you can generate the output to let the machine running, or depending on the status of the safety protective equipment, also stop the machine. How does it look like? So you can see here the connected safety mat. You see it has usually 2 contacts as for safety. It's connected to the safety input of our digital input module. And then you just connect this input, which you define as a variable in our safety program, connect to the input of SF_PSE function block. And then again, depending on, of course, status of activate, reset, and the others, if you configure this correctly, then you can control, for example, the output, safety output of our DX581S module, and then trigger, for example, a contactor or safety relay. Could be two contactors depending on the safety level or performance level you would like to reach in your safety application. So again, very useful function block. Before that, customers had to do their own solution or use other function blocks in combination to reach the same functionality. The third function block which I would like to show you is Enable Switch 2. It's again new one. It enables you to evaluate not only 3 position enabled switch devices, but also 2 position. And when we talk about 2 position, it means it doesn't do any detection of panic position. So usually in these safety related enabled devices, if someone gets scared, then usually it's expected that he's not able to keep a valid position. For example, it could be joystick or some other device, and joystick is quite well known, so he has to put it on the left side or on the right side. And the middle position, for example, means that he is not active and the safety function has to be triggered. So the enable switch function block could handle that, but if you don't need this panic position, so the third position is not needed, then you would have to again work around something for you in your safety application. Now with this function block, you can cover also 2 position. And in this case, I showed here 2 push buttons, for example, because you don't have any panic supervision. Thus, it doesn't have to be any joystick or some other special safety devices for that. You just can use standard switch devices with, for example, 2 positions. But still, you can also use, depending on the configuration, you can also use a 3 position switch. How it is used? The next one is the override. The override function block enables you to move a product in the production line even when the muting functionality was aborted. So imagine you have a machine and you have a conveyor, and for example, these pallets are transported inside this machine, for example, for cutting operation, and something happened and you're not able to push the products further, and you have the situation under control. You would like to clean this area for whatever purposes, and with that function block override you can do this. And independent on the state of the muting sensors, which are usually positioned here, they are not shown, as light curtain is also not shown, so light curtain is usually positioned here. You have also muting switches for detection of the products, so you can override them. And to do this actually by connecting this override push button to the S_start stop override input. Others inputs have to be also properly connected, of course, and then you can use this function block in the application. So the fifth one, it's a guard lock-in 2. It allows you to have a safe control to the hazardous area. I will not go deeper in this function block because it's basically supervising a sequence for an entry into safety area, for example, in a robot cell or some production part of the machine, and expects from you a certain sequence of events. So you see, you have to connect your guard. Guard could be door access switch. You can lock this door depending on the lock state so that the machine can keep production. Before you can use this S_guard input, you have to unlock first it and then come in. And usually most of the signals are implemented either in a set of position switches or even inside of one device which has a handle. It has these lock buttons and so on, and the operator has to know it, and only if he's doing all these operations in a certain sequence he gets a control and enters to this area. So the guard lock-in 2 introduce one more approach in addition to the previous function block which we had in PLC Open Safety version 1 library, and covers also this special case. For more details, I would recommend to go to the AC500S safety user manual because there are many special details on that. Similar comment I would like to say also for guard locking. Serial, this is usually done when you have a serial connection of locking devices. Again, you can unlock this device, you have again S-guard, and there is again a supervision for second sequence, how you can unlock these special devices, which are specified by safety standards. So if you look in the AC500S Safety User Manual, you'll quite often see that most of this functionality is also specified in relevant safety standards. And these function blocks, they just cover these functional requirements for particular applications in a certain way. With that, we've covered now the six function blocks, some of them with more detail, some of them with less. Now we'll come to the safety application as an example, how we could use some of these safety function blocks from version 2 with PLC Open Safety version 2. And the purpose of this application is to show you why these, for example, safety outputs like safety demand, reset request are so helpful in the application and give you a little bit the feeling how this safety functionality works and behaves. So what do we have here? We have a small cutting machine, which with these pellets are fitted here. And after this cutting process, they are cut in pieces. You see they are coming with 6 pieces out of that after the cutting operation and go to the next machine, for example, for labeling or for packaging. What we need here, we'll cover only the cutting machine part here. What we'll need is a two-hand control device. For that, we used ABB has in its portfolio from the electrification this product. And you see left hand is put here, right hand is here, and then you have your emergency stop button here to stop the operation in case of emergency. In addition to that, and then both of these control devices, so this is two-hand control here and emergency stop, are separately connected to the inputs, safety inputs of our DI581-S module or DX581-S module. In addition to that, so if we trigger, for example, emergency stop button, or we don't trigger our two-hand control, then we can safely stop the motor using these contactors by de-energizing the motors, and will supervise readback contacts from two contactors. And there is also a reset button, because usually if we press emergency stop button, it's not enough just to again put it to initial position. The machine will not running. You have to actively reset it as it is required by current safety standards. That's why reset button is usually needed. And I've skipped also some other control elements here, like usually you have also some start button to start the machine. It is sometimes connected to non-safety inputs depending on customer choice or particular safety requirements. So if you look at this on these devices, you can implement emergency stop function. That's what you've seen here. You have a two-hand control safety function. So by pushing only both of these push buttons on the left, on the right, only then, so making sure that both your hands are used. So you cannot put your hand inside this cutting area, which would be very dangerous, of course. You can cut your fingers or your hand. For that purpose, it's important that both of them are triggered. Only then the cutting process continues. And then we have, of course, a safety-related stop. If you remove your hands, then these contactors are triggered and they de-energize the motor. We don't cover here, of course, safety function response time and other things for simplicity. At the end, the overall application is, of course, much more complex. So we focus only on handling the logic behind these devices connected to these machines. And I will also demonstrate this in this application using live demonstration. So here, the next level of explanation, what do we connect where? First, we have emergency stop function block for emergency stop button handling. This is what I mentioned, and this is part of our PLC Open Safety function block. This function block was already in version 1. So in version 2, if you compare, you'll see that the safety demand and reset request were added. Other than that, the functionality inside is very similar to what you had before. All of the outputs are connected to some variables. Here, for simplicity, I put some constants as inputs. Normally, you would put also here some variables. The second function block is a two-hand control, and this is what you see here. So these two position switches, which can be triggered or push buttons, they are connected to switch 1 is this one, and switch 2 is for this one, to another function block, which handles again the logic behind, so that the output is triggered only if a valid state for these switches is observed, also in the sequence in relation, for example, to the process input and so on. That's something I will demonstrate in the live session in a second. Then we have reset button. Yeah, first we have our contactors, of course, to control contactor outputs. We use EDM function block so that we can trigger the contactors and then also read back directly their states. Usually they have forcibly guided contacts for readback, which allows them to be used in safety applications. So they provide us the feedback if they are triggered or not. And by doing so, we have our safe diagnostic coverage for these electromechanical devices, as they may get broken over the time. And electromechanical devices, it's quite well known that they can get broken over the time. And with that, the expectation is that one of them only can get broken. Then you see it from the readback, and then the second one keep going, and then you still have your second shutdown path for safe stop application. And then the reset button is used later on. I will show it. So how does it work? The logic behind is that only if emergency stop button and two-hand control have a valid state, and that's what you see here with their outputs, only then we allow this out control driver. It's a driver which later on goes to this EDM function block. So it's used for collecting the signals from different devices and basically allowing you to activate the EDM function block. So only then you get an activation here. So the machine is running or it is stopped if something here it go into the off state. And when the machine is stopped, for whatever reason, either because of two-hand control or because of emergency stop, then you will need this reset button, and then it is connected here to this S0 reset inputs. This one doesn't need reset. That's why you don't have here the input. But again, here reset and here reset. And of course, you can have multiple reset buttons depending on the application. In this case, we used one reset button to reset everything. Short explanation what you will see, and now we go to the live session. So I'm here with my safety project in AC500S safety programming tool. I have my application running. I have also my simulation system here, and this is the initial state of my machine at the moment. What you can see here is that my safety output is still off initially. For your information, if you have the blue color, the state is true. If you have the black color of the output, the state is off and false. So you see that the emergency button, for example, is not triggered, so it's active. And what you can see already here, this is again a very good benefit. So you can read today with version 2 directly that before the output of emergency stop gets active, which would allow you, at least it's one of precondition that the machine can get running, first you have to reset it. And that's what I'm going to do. So I have my switch also here, push button. on the table, you'll see that I reset it, and reset was triggered here. For simplicity, I didn't use this reset function block, which I showed before. So I'm focusing just on these 4 function blocks. You could use also for this reset button also intermediate function block with the reset and this minimum trailing and maximum trailing. Here, for simplicity, I skipped this stage. So what you see here is that the emergency stop button precondition to start machine to start running the machine is there because the output is active, and it's also propagated here. So the out control would be potentially ready from the emergency stop button perspective to start the machine and activate the out control. But there is a second precondition which is missing, and this is our two-hand control. And the two-hand control requires first that I activate the process and say, yes, the process is running. This is what I will do with another switch. And with this process activated, you see directly that the safety demand output is set. It means, okay, please press these 2 push buttons so that I allow you to get here the true value on the output, and the precondition for activating the machine is there from the safety point of view, and it can start running. But for that, I have to press these 2 switches, switch 1, switch 2, and that's what I'm going to do. So first one, second one. And what you see, as soon as I pressed both switches together, so currently I'm holding both of them, virtually I'm simulating, of course, here, the two-hand control output is activated. So we have 2 preconditions for our out control. Both are active, and now the output is also active. It's propagated to the EDM function block, which activates both contactors. And you see that the readback is also in the right status. It's currently off because only if I switch off here the outputs and the contactors are de-energized, then the readback contacts get positive. So it's de-energized to trip state. So currently the machine is up and running. Everything is fine. And what I will do now is I press my emergency stop button. I have a real one here, so I'm pressing. So what happened? You see that the emergency stop input from my emergency stop button went to off. The output of the function block again is de-energized now. Because of that, of course, the out control also is de-energized, and it propagated to the EDM. So now the output is off. Both contactors are de-energized, and that's why their readback contacts are active. So I can supervise that the state is safe for the machine and it's not running. And the good thing here, again, now for emergency stop button, you see, okay, to restart the machine back, I have to take back my emergency stop state, and then the machine can run. So that's what I'll do in parallel here. I pushed emergency stop button back to its initial state when it's not triggered. And now the function block tells me at the outputs, okay, you fulfilled this requirement for safety demand, fine, but still please reset. And again, you see it as an output. Before it was not possible. So now you just reset it. And what do you see? You see that there is potentially an error, which can happen if, for example, the conditions for the machine are not done in the properly sequence. That's what you see here in the out control. The expectation from this out control was that first the emergency stop button is active, and only then the process control part comes, and not the other way around. For that purpose, we'll take the process control back, and this is what happens. We deactivated these switches and the process completely, and now we will restart it again. So we try to activate now two-hand control. Again, tells us, okay, so safety demand, press 2 buttons. We do it. 1 second. Now this condition is fulfilled, and now again machine is up and running because this output is active. So this gives you just a short feeling what's going on in the safety application. So it's really a lot of internal states, sequences of signals, how they are coming, just to avoid undeterministic, unexpected states, because again, we are talking about protecting people, environment, and also sometimes investments from accidents. And for that purpose, many formal things have to be fulfilled. And PLC Open Safety version 2 function blocks give you this standardized behavior inside for all these events. So if you would go to another brand, there are some other function blocks for similar functionality. They look different, they have different outputs, they have different inputs, different naming. You can get completely confused, and it's really from brand to brand. Here with PLC Open Safety, all these typical functions in the machines can be standardized. You can have a common look and feel between different PLC brands, and this is a big benefit. So now I would like to log out here and go back to the presentation. Now the final slide, the summary. So we've launched PLC Open Safety Library version 2 in Automation Builder 2.7. We have now 22, you see here the list of these function blocks, which you can connect together and implement all kinds of safety functions, especially in simple OEM machines. We have the biggest offer at the moment, together with 1 or 2 other companies at the moment. I think that others will follow, of course, because the specification is there. And with that, you have a common look and feel. The customer investment in these safety applications is protected. He has much more freedom later on with these applications if he decides to change the vendor or would like to do some modifications in the program. He can be fast in his application development because we have a very detailed, good documentation, explanation, and specification if you look in our safety user manual. And we think that he can be much more flexible in the engineering. And today we've seen also the benefits of our version 2 library, 6 new function blocks, and also additions with safety demand and reset request, and how useful they are in safety application based on a very small example of metal cutting machine. Have a nice day. Bye-bye.